Hello, let's take a brief intro and overview to the Python programming language and provide a little bit of context. If you're not a programmer, you should still care about programming and Python in particular because it is one of the most popular languages for data science work. Also, you might be the one at your company to pick a development language or contribute to that selection. So it would be very helpful for you to have a good idea about advantages and disadvantages of Python. You also may be someone at your company who interfaces with developers. I'm reminded of my father-in-law who finished his career as a regional manager in power generation at Westinghouse. He told me once that he took a programming course well into his career, well into his management phase of his career, simply because he wanted to learn the lingo and understand what he was being told. And he made a joke out of it. He said, I took the course so I could figure out if my programmers are lying to me. He said that totally in jest, but he's making the point that you don't have to be a programmer these days to benefit from some knowledge of development. You may have to talk about it to other interested parties like your boss, your peers, customers. Why are you using Python? Why did you choose this language to do this job that we hired you to do? And in the software development world, we have a meme that refers to explaining things to a rubber duck. The implication is that the duck has no capability to understand anything. Therefore, if you can explain a concept to a rubber duck, then you're really good and you must be well versed in that concept. And that little guy comes up quite a bit. Or maybe you just like to write code and maybe you get a kick out of this like I do. And that's another good reason. Here's a broad comparison of two languages. They're both general purpose languages. Python certainly has developed a reputation for data science. And C Sharp is, they're not identical languages. They have a lot of similar constructs. They're both procedural. They both have functions. They both have object-oriented capabilities. So while they are not one-to-one replacements for each other, if you gave me a Python program, I could convert it to C Sharp and vice versa. It might not be the easiest task in the world, but it would not be impossible. So C Sharp is completely OOP. We don't have the opportunity, we don't have the option to create non-OOP C Sharp programs. Python, on the other hand, allows us to write lines and lines and lines in complete applications without doing any object-oriented work. Actually, this course will not delve into OOP at all, so you'll see that's the case here in the coming weeks. Python is not compiled, it's interpreted. C Sharp is compiled into an intermediate language, and then that intermediate language is interpreted. So we call it a hybrid compiled language. C Sharp requires you to tell the compiler what data types you're working with in advance, and Python does not. And we'll see more of that as we go along as well. This is a sticking point, might not be the right word. It is a point of contention, that might not be the right word, but it is definitely a line of demarcation between different programming languages. If a programming language is dynamically typed, that tells you a lot about what people do with that language and what it is intended towards, kind of beyond the scope of this class, but that is something that we look at as developers. Both of these languages are popular in the sense that you can get a job, you can solve problems, you can develop applications, you can find many, many third-party libraries. They're not going anywhere. If you hitch your wagon to C sharp, there will be a C sharp in the future. If you line yourself with Python, there will be a Python in the future. And even if Python tomorrow were to stop developing itself or the community gave up on it, it would still have plenty of momentum and it would not fade away. Cultish, this is just, I'm poking fun, I think, at Python a little bit here. I don't mean this to denigrate the language at all, but you won't find a lot of C sharp users, developers who are wildly addicted or are tremendous advocates. It's a tool. It's owned by Microsoft. I think that sets the tone for a corporate language. Python, on the other hand, was developed to be open source, to be community supported. It had a figurehead that you could point to and say, yes, that is the person who started this thing, and therefore it's on the boundary of cultish. That's, again, not a bad thing. I'm not saying that's a negative. I'm just pointing out differences between the two. Execution speed, getting into a little more quantifiable comparison than cultish. Execution speed, I think, generally speaking, on the whole, a C# program will run faster than a Python program. And there's certainly ways of optimizing all programs, especially when you're processing large volumes of data. And execution speed, while it is important, it may not be as important as the flexibility and availability of specific third-party libraries, depending on the volume of data that you're processing. So again, in a broad sense, broad strokes, C# programs, yes, going to be faster. And hardware has advanced to the point these days to where a lot of things that concerned us relative to speed don't concern us anymore, simply because we can add a few more cores to the mix. And Python doesn't have the best reputation for parallel programming, but it still holds its own, even though we would consider it to be a quote-unquote slower language. Cost, C# is owned by Microsoft, controlled by Microsoft. Therefore, you may find that purchasing the tools that you might need could cost you some money. There are definitely some ways to get into the C# development arena for free. Microsoft has been moving in that direction. Python was created with the understanding or the intent that it would not cost money. And everything that we use in this class is open source or at least free. So again, a lot of overlap, a lot of gray area there. And finally, kind of silly, but a C# file ends in .cs and a Python file ends in .py, which really has no effect on anything. And as soon as I told you Python is an interpreted language, I can go online and find examples of Python as a compiled language. So it's not a hill that I want to die on. It's not an argument I want to get myself involved in. But the previous slide again, that chart was speaking in generalities. And any tool, any software tool that evolves over time, and Python is actually older than Java, believe it or not. It's been around for, in computer time, a long time. Any tool that's been around that long, there will be people who stretch it to do things that it didn't originally do. And I really get a kick out of that second snip that I provided for you here. There is a operating system called Cleese, which is named after John Cleese, one of the members of Monty Python. And it is an operating system, an OS, written almost entirely in Python. And nobody thought that Python was going to become a tool for writing operating systems. I mean, it was an interpreted, dynamically typed language that just did not lend itself to that kind of coding. And I'm just showing you this to give you a feel for, and I'm gonna refer to this as maturity, the maturity of the language, meaning that it has been around sufficiently long and it has proven itself to be sufficiently interesting and useful that people have stretched it well beyond its original intent capabilities, which are very interesting. One measure of popularity might be this index. I don't know how to pronounce this, Tiobe, but I have provided the link for you there if you'd like to look at it. And according to these folks, and it must be true because it's online and it's on a website, it's published with a table and a bunch of text, right? So it must be true. According to these folks, Python is right up there in popularity. This is something you should definitely take with a grain of salt because if you want a programming language to control the next space shuttle mission, you probably wouldn't pick it from this table based on popularity. It's just not something you would do in Python. But it is interesting that according to whatever metric they came up with, and I encourage you to take a look at it just to get a better feel for where we are. According to this metric, Python has persisted in popularity, and it remains right up there with Java and C. I think that C being as high as it is on that list is even more impressive than anything else because C is, again, in computer time, an old language. And the fact that it has persisted since the 70s and still shows up as a competitor with Java and Python and C# is very impressive. Now, does that mean that we should scrap this course and all go learn C? No, absolutely not. It's a different beast entirely. We can come up the curve much more quickly in Python. Here is the world's simplest program, Hello World, implemented in C# and in Python. I've chosen C# because it is just another mainstream popular development language that you might do similar things in that you do with Python. And I'll give you an example. I can start up the Python interpreter with a few keystrokes. I can run the Hello World program in a few seconds. And in order to do that in C#, typically start Visual Studio or an equivalent, create what's called a solution. Inside the solution, create a project. Inside the project, create a module, a C# file. Inside the module, create a class. Inside the class, create a method. Finally, inside that method, write console.writeLine and then hello world. And if you focus on the slide, the actual code that does the work, I've highlighted there. Everything else is framework. Now, one thing this tells you is that Python is going to attract a lot more entry-level, curious people because you can get up and running so much more quickly. Another thing that it might tell you is that C# might be better for enterprise level work because it does have all this scaffolding that lets you do things in a more enterprise, quote unquote, way, dividing up your work amongst developers and rigid levels of segregation between units of work. Whereas Python, I just wrote one line of code, and where did it go? Did it get saved? Is it part of a project? Is it even in a file? How do I recall it later if I want to do it again? And I know that I skipped a lot of steps and I left out a lot of things, but I think that if, again, you take this in a very broad sense, you can see that which one of these would I want to teach to a high schooler, or which one of these would I want to learn if I wanted to be productive quickly. And from my experience, I'm going to get 6 months or a year down the road, I might start thinking, how do I make this Python program more enterprise, more scalable? And I might realize that looking back, a C# solution/project might have been a better idea if I had started with scalability in mind. And I'm not denigrating Python. I'm not reducing its impact. I'm just pointing out the differences. Dynamic typing. I mentioned it earlier when I showed you that graph. I think that it is a significant difference between, and we're still comparing with C#, but this also applies to C++ and C and Java. Now, JavaScript, you may have heard of the language called JavaScript. It is dynamically typed. Python is dynamically typed. There are other languages also that are dynamic, and they're that way for a reason. It wasn't done capriciously. But I don't need to tell the compiler, the interpreter, sorry. I don't need to tell the interpreter what kind of data I'm about to store or where I want to put it. It infers data type. In this case, it infers that x is an integer because I stored a 42 in x. I can easily change x to another data type by storing something else in it. Instead of storing a 42 in x, now I'm storing quote 42 close quote, which is a string, a different animal entirely inside the machine. When I print the data type of x, now I get string, str. And I will tell you, as a developer who was raised on statically typed languages, that I find this to be a hindrance. I find this to be an opportunity to make mistakes because there is no tool built into the little Python interpreter here that can tell me I might be making a mistake based on mismatched data types. Now, there are some utilities that I can run against my code to detect some problems with data types, but not all of them. So if you're looking at Python from the perspective of getting things right the first time, maybe making less mistakes, I would say it has a shortcoming there because it is dynamically typed. However, remember that it's that way for a reason. It was created that way to allow it to be, to allow you to write interpreted programs and to not have to compile them. So again, not looking to start a fight, not looking to build any animosity. I'm just giving you my perspective on that. Another difference between Python and C Sharp and Java and C++ and C and other languages is the way you format loops and if statements and functions. In Python, we simply indent to indicate a statement is part of a loop. In C Sharp, we use a set of curly braces to delimit the statements in that loop. Takes some getting used to. If you come from one environment, you find yourself typing curly braces when you really weren't supposed to, when you try to migrate to that new environment. There is no inherent, well, I take that back. There's some inherent danger here if you don't indent consistently, but we live with it. We always want to write modular code, therefore we look at functions very closely. A function is a named piece of code that you can invoke by that name. And if that function is part of a class, then we don't call it a function anymore, we call it a method. A method is just a named piece of code that's a member of a class. So in Python, we can create functions, named pieces of code that are not part of a class, and we're off to the races. You can see how easy it is in that example there. I've also introduced here very subtly the concept of a fiddle. And let me bring up the fiddle for you. I don't know where the term came from, and that screen looks like a mess. That doesn't look good at all, does it? How about that? The concept of a fiddle is a web site that lets you write code and run it. There are Java fiddles and SQL fiddles and JavaScript fiddles. So it's another quick and dirty way to spin up an interpreter very quickly just to test a concept. And I can do my print statement here. Click run, and hopefully I'll get the output somewhere. I don't see it anywhere. I think the CSS is a little bit of a mess here. Let me try this on a different browser. Here I am in Chrome. I'm trying to load pythonfiddle.com. Frankly, I have not had these problems before with Python Fiddle. It might not be a well-maintained site anymore. There are plenty of fiddles. I just had centered on this one because it was in the slide that I created. But the certificate associated with this site appears to not match the site. And that's an indication of either someone is trying something devious or they just let the certificate expire. And it says that Python Fiddle is sending me a security certificate from Fiddle Salad. And I have two choices. I can continue on and assume that that's just a clerical error on the site administrator's part, or I can bail out and run away because I'm scared. And I'm going to live dangerously, and I'm going to proceed to the site and say the certificate's probably okay. It still looks like a mess. The go button is this go button is laid over top of some of the text on the screen. There's a radio button inside of an input box. I'll tell you what I'm going to do then. I'm going to bail on Python Fiddle, and I'm just going to search for other sites that might do the same thing. Well, the first result is pythonfiddle.com. Apparently, Google still has a pretty high opinion of that site, but we didn't have any luck with it. Let's try the next one. This one is mycompiler.io/online Python compiler, and we click the run button. I think it will take us to a fiddle page. There we go. This looks better. Looks way more friendly. It already gave me Hello World as a practice little program, and I can click run. There's the output of that program, and then there are 3 buttons here. I can switch back and forth between the code view, the input, and the output from that. Okay, circling back to the slide, what we were hoping to do then was write a function. That's where we started this odyssey. And let's do that. I'll just make this into a function. def colon say hello colon indent. There's my function. If I very carefully backspace to column 1 again, I can call the function. Whoops. There we go. Say underscore hello. The code starts running here because that is the code that's not in a function, and the interpreter figures that out. So the interpreter realizes to begin running the program at line 5. It realizes that line 5 is a call to the method in line, or the function in line 1. Sorry, I called it a method out of habit. If I click the run button over here, I get the same output, hello world. And our goal was just to demonstrate how to create a function. You may want to use your own search engine and take a look at different fiddles. If you're familiar with other languages, you might be able to find a fiddle for that language as well. I use them for just this purpose, to demonstrate very simple concepts, or to paste in a little piece of code to see what it might do if I'm trying to debug a very small piece of code. I certainly would not write any program of any significance at all in a fiddle. In closing, I have provided a link to a research paper that compares 6 different languages, including C# and Python. Referring back to the opening of the slideshow, all of these different bullet points that I gave you here as to why you should care about Python, all of those are relevant to studying this research paper and getting a good overview of the languages and how they relate to each other. Of course, compilers and programming is a field of study, or many fields of study, so it's not something that you're going to get completely familiar with in one paper, but it will give you a good start. And the more overview you have, the more broad feeling you have for which programming language might be better than the other for certain things. But I will say that it's not a crusade in my opinion. I have strong feelings about languages because that's what I do. That's the interest that I have. Teaching compilers, using compilers, designing language tools, but it's not something that I'm going to go to battle over. So don't take it personally if I've hurt your feelings about Python. I apologize, and I think we'll have a great time together this semester. Thank you.